Hello friends, welcome to Kavita's classroom. Today's topic in hand is regarding consumer equilibrium, and before proceeding ahead further, kindly like, share and subscribe. So what do we mean by the term consumer equilibrium? Equilibrium is a state of rest. Rest means we do not have any tendency of change. Neither we want to have more or less. It's giving us the maximum satisfaction. Before also I've given you the example. For example, I am a consumer and I take two chapatis in one meal, right? So if I'm taking one chapati or three, either this side or that side, both ways I'm not satisfied because either I'm underfed or I'm overfed, and both the things are not okay to me. So consumer equilibrium is that state of rest where I am okay, I'm most comfortable, and I do not have any tendency to change. So when we talk about the consumer patterns, means how much we are buying. Should we buy more? Should we buy less? So this chapter will help you know about these things. Right. So let's proceed. When we talk about a consumer, who is a consumer? Who consumes any goods or services? So it's not merely edible things or eating, it's services as well. If I'm taking the services of Ola Uber, it means I'm a consumer of the services, right? And why do I consume? Because I want to have the satisfaction of my wants. Right, because that good or that service is giving me some utility from my expenditure. Then comes the term, what is utility? So utility is nothing but the want satisfying power of a commodity. Right. Here comes a contradictory question, and most often the question put up by the students, Ma'am, is this bangle giving any utility to you? It's not doing anything good to you. If it is not doing any good to me, then why am I wearing it? The showpiece in the corner of the room is not giving me any utility. How? Then why have I put it? That's beautifying my area. So anything which is satisfying my any physical, psychological, human, any want is utility. So anything which is giving me that thing, that satisfaction gives me the utility. So here comes the expression of two renowned experts, economists, Alfred Marshall and Hicks. Right. Marshall said that utility can be measured and we measure it in the unit called utils. For example, if I'm taking one apple, right? So he said that if you consume an apple, you can say that yes, you have got a utility, say worth 10 utils, and then the next apple will give me 20, less than 10 means 8 utils, or next apple will give me 5 utils, right? So he believed that we can measure the satisfaction in cardinal numbers, numbers like this 1, 2, 3, 4. But it was straightaway objected by Hicks. He said, how can we measure it in a number? We may say, yes, I've got the satisfaction after eating an apple. I'm pacified now. Or he may say that, yes, apple gives me more utility than banana. So he said that the things can be expressed in high or low, good or bad, more or less, means these relative terms will give the utility. So he said the utility cannot be measured, it can only be ordered. That's why we say that Alfred Marshall gave the cardinal measurement, but Hicks gave the ordinal measurement. Ordinal means it can only be ordered in high or low, it can only be ranked. So this is the crux of or the definition of these cardinal and ordinal measurements. So first we'll begin with the cardinal aspect, and for that we need to know about few terms like total utility, marginal utility. Total, as the name suggests, total means the sum total of all the units, right? For example, as I said, first apple gave me 10 utils of satisfaction. Utils like force, we have some units, weight, we have some units. Similarly, the unit of this utility is utils as coined by Marshall, right? So first apple gave me utils 10 and second apple gave me utils 9. So what is the total so far? It is 19. So 2 units gave me total utility of 19. This is the same example given here. Now, when we talk about marginal, marginal means in our previous lecture also we talked about this, that whenever we say marginal, marginal means additional, the next number. So when I have already had one apple, so when I say what's the marginal utility given by the next apple, means not two together, it is only the second apple. What is it giving? Right. So it has got a formula that is TUN minus TUN minus 1. You must note that n and n minus 1 are nothing but the, continuous numbers. N, if n is 10th, n minus 1 is 9th. If n is 100th, n minus 1 is 99th. Means the preceding number. So they say, if I want to measure what is the mu given by the second unit, I will have to check the total up till 1 and total up till 2. So the total up till 2 is 19 and total up till 1 is 10. So what is the difference? The difference is 9, and that is what the mu is. Mu means the marginal utility given by the second unit. So here the formula becomes the marginal utility given by the second apple is the total utility given by second apple minus the total utility given by the first apple. Here we had 19 minus 10, and that gave us 9. So, in a very similar note, if you have any fictitious table and they say that 1, 2, 3, 4, 5, these are the the units of some commodity consumed, right? So this is the total if they have given. So can we find mu? We can find mu from TU and TU from mu. Just try to understand. This is the total, right? And marginal is TUN minus TUN minus 1 means the total till this value minus the preceding total. So what is it? 190 minus 100, that gives you 90. If you want to check out mu at fifth level, so mu at fifth level is TU at fifth level minus TU at fourth level. That is 400 minus 340 gives you 60. So this way we are able to understand what is mu. But are you able to understand how can you calculate TU? Now let's derive it from this very table. TU till 1 is 100, right? TU till 2 would be 100 plus this 90 which it has given the additional unit, that is 190. Then next is you have to add 80 in this preceding value, that gives you 270. Then you have to add 70 in this preceding total, and that gives you 340. And you have to add the 60 in this preceding 340, and that gives you 400. So what's the formula of TU? TU is sum total of all MUs, and mu is TUN minus TUN minus 1. And this relationship can be beautifully explained through the help of a diagram as well. So when we talk about this TU and MU relation, this is very much expected question from paper's perspective and is asked very often for 3 to 4 marks, right? So when we say if the first unit gives us the satisfaction of 100, right? So because it's 1 so far, this is the total and this is the marginal. So TU and MU begin with the same value. But every next additional unit gives us lesser and lesser of satisfaction, and this would be explained in the next upcoming video when we talk about the law of diminishing marginal utility. For now, you may understand that whenever we are writing MUs should be falling. So when MUs are falling this way, it is a downward sloping curve, and TU would be because every addition to the previous gives you TU. So TU, if you just make by yourself, start from any point, right? Make it down. This is MU, and you have to make it up, and this is TU. And if you want to be very technical, here I'm giving you the extension. If you make MU intersect x-axis, right? So this is the point of reference. You have to just plot it up. And here TU would be the maximum. And then afterwards it starts falling, right? And this would be precisely done in the next law law of diminishing marginal utility. So when we talk about the relationship between TU and MU, for 4 markers, what would you do? You would be giving the formulas, like you can get 1 mark by this set of formulas. You can get 1 mark by simply giving the definitions, that TU stands for the total utility and MU stands for the additional utility of every next unit taken up by the consumer, right? Then you talk about the schedule and curve when you are done fully. And if you want to give a reference, like you can say that when MU is falling, see from this diagram, when MU is falling, TU is rising. When MU is 0, TU is maximum. When MU is falling and is negative, TU starts falling. So this is the precise relationship between TU and MU and is the best and the most expected question from this section. Now, the relationship between the two has now been explained, as I told you, that when we talk about, and this can be plotted in one single piece of x and y axis, one curve, or you can give 2 curves, right? So they are beginning and, making TU rise, move it to its maximum value, and then start falling, right? MU begins and MU starts falling and then becomes negative. So if you are plotting this way, or if you are plotting like as we plotted earlier, it's one and the same, and you get to have full marks. So this is the point of reference, and till this point, TU would be rising and then TU would start falling. So whenever this relationship is asked, this box is the most vital, and it says TU increases so long as MU is positive, because till this point TU is increasing and then it's getting stabilized and it's the maximum value. TU is maximum when MU is 0. MU is here on the x-axis touching it, right? So it becomes 0. TU starts declining when MU is negative. Yes, we see it. Afterwards, MU is down the x-axis and TU has started the downturn. And decreasing MU implies that TU increases at a decreasing rate. Decreasing rate means now it has started falling. Means it's increasing at a decreasing rate. See, when I add -1 in 5, what is my answer? My answer is 4. So now it is increasing because I have given the addition sign. At a decreasing rate, it means it's instead of rising up, it's showcasing a downturn. I hope you understand. So with this relationship between TU and MU gets over and the basic understanding gets over. We do have some sort of relationship, some examples, like when TU is given, can you find MU? Yes, just simply keep on subtracting this and you get to have MU found. Or when MU is given, you can just keep on adding the two and you land on TU. So with this, we just close for this moment. See you in the next video for Law of Diminishing Marginal Utility. Take care. Keep studying hard. Bye-bye. Your comments are awaited.